Good morning, afternoon, or evening, cats and dogs. This video is going to focus on the lesson 6.2 and 6.3 guided notes, solving one-step equations by multiplying or dividing. Now, just like when we solved one-step equations by adding and subtracting, we also have the multiplication and division properties of equality. And just like those rules, it basically says that what you do to one side of an equation, you have to do to the other. So either add the same thing to both sides, subtract the same thing to both sides, multiply or divide the same thing on both sides of your equation. Now, this box that I'm about to go over, and I'm going to put a little highlight here in yellow, just in the corner of this box, because it's really important. It says the inverse of multiplying by a number is dividing by that same number. The inverse of dividing by a number is multiplying by the same number. We only have one inverse for multiplying and dividing. That's going to be really important for us moving forward. So there's only one inverse for multiplying and dividing. Why is this the case? It's because multiplying is not the same as dividing by the opposite, and dividing is not the same as multiplying by the opposite. When we did adding and subtracting, remember that we had more than one inverse we could use to solve that equation. And that was true because subtraction was the same as adding the opposite. We don't have that here for multiplication and division. So there's only one inverse. So the only inverse of multiplying by a number is dividing by that same number. And the only inverse of dividing by a number is multiplying by that same number. That's really, really important for us. So please pay particular attention to that note that is in that box. All right, let's start by writing the inverse for some of these statements. So number one, it says, what is the inverse of multiplying by -8? The only inverse we have is dividing by -8. Remember, we do not have any other choices. You cannot say multiplying by +8. When we did adding and subtracting, you could change either the operation or the sign. We don't have that choice here for multiplying and dividing. So the inverse of multiplying by -8 is dividing by -8. Number two, what's the inverse of dividing by 5? It is multiplying by 5. Number three, what's the inverse of dividing by 5.68? Well, it's multiplying by 5.68. Number four, what's the inverse of multiplying by 1/3? Think about that. It's dividing by 1/3. Number five, what's the inverse of dividing by -4 and 3/5? It's multiplying by -4 and 3/5. And finally, what's the inverse of multiplying by 4.8? Dividing by 4.8. Hopefully you see in these examples that there's only one option. Again, you cannot change the sign on the number here. It has to be changing the operation for multiplication and division. Really important for us. All right, let's get it right into our examples. So numbers 7 and 8 are already done for you. The directions say to solve each of the following equations. Show your inverse operation and any side work. Now, for these, we luckily don't have to show side work because we're going to be using our calculators to find our solutions. So in number 7, our equation is 2x equals -8. What's happening to the variable is we're multiplying by 2. The inverse of multiplying by 2 is dividing by 2. So you're going to see that I'm going to show that inverse operation. That's the only option, one time on each side of our equation. 2 divided by 2 gets us 1x, which is just x. So what you're going to be plugging into your calculators to get your solution, or doing mentally, is -8 divided by 2, which is -4. So our solution is x equals -4. Remember, you can check your solutions by replacing -4 for x in our original equation. So you can do 2 times -4, hit equals. It should get you -8, and it will. All right, in number 8, what's happening to the variable g? It's a fraction, but the fraction bar represents division, so we're dividing by -5. The inverse of dividing by -5 is multiplying by -5. So you're going to see that I'm going to show that one time on each side of my equation. You can do it right underneath, which is what I will do when I go to show my work here in the next few questions. But the -5s will cancel out here, and we see why over in this box on the right-hand side. Basically, it's multiplying g over -5 by -5 over 1. And what will happen here, my my lines here that cross these off seem to have gotten misaligned. I don't know if it's like that on the paper. That happens sometimes. But these guys will actually cancel out, and you'll be left with g over 1, or just g, since g divided by 1 is g. And then you'll have 6 times negative 5 on the right-hand side to get your solution. A lot of times students get confused. They're like, does that really cross off if I multiply by negative 5? Shouldn't that be a 25 on the left-hand side? Take negative 5 times negative 5. Not quite, because if we divide by negative 5 and multiply by negative 5, those things undo each other, which is why we use the inverse, and you end up just being left with the variable g in this case. So you get g equals negative 30. Remember, you can double check your solution. You don't need to put it in as a fraction, but replace g with negative 30. So do negative 30 divided by negative 5, hit equals. As long as your calculator gets you 6, you are correct. All right, let's take a look at number 9. So a over 12 equals negative 3. What's happening to the variable? Well, we're dividing by 12. What's the inverse of dividing by 12? Multiply by 12. So what I'm going to do is I'm going to show multiply by 12 on both sides of my equation. Again, always the inverse. You can write it right underneath like I did here. So what are you plugging into your calculator? You're going to plug in negative 3 times 12, which is going to get us negative 36. So our solution is a equals negative 36. All right, let's take a look at number 10. What's happening to the variable in number 10? We've got negative 5x equals negative 25. Well, it's being multiplied by negative 5 since we have negative 5 times x. What is the inverse of multiplying by negative 5? If you're thinking divide by negative 5, you're correct. Now, a mistake I see students make a lot on this kind of problem is they think, oh, I've got a negative 5 there. I should just add 5 to both sides. But what's happening to the variable is multiply by negative 5. So the inverse has to be to divide by negative 5. All right, let's show our inverse one time on each side. So we're going to divide both sides by negative 5. What we're plugging into our calculators is negative 25 divided by negative 5. So our solution will be x equals positive 5. Remember, you can check your solution. Do negative 5 times 5 in your calculator, hit equals. It better get you negative 25, and it will. All right, let's go ahead and take a look at number 11. 7x equals negative 49. What's happening to the variable x? We're multiplying by 7. What's the inverse of multiplying by 7? It's divide by 7. Remember, at any point, if you feel the need to either pause the video to copy things down, or maybe pause the video to try some questions on your own, you can do that. So let's show our inverse once on each side. That's going to be to divide by 7. Show that on the left and the right. So what do we plug into our calculators? Negative 49 divided by 7. So our solution will be x equals negative 7. Number 12, we have negative 9 equals y over negative 4. Remember, the fraction bar represents division, so what's happening to the variable is we're dividing by negative 4. What's the inverse of dividing by negative 4? It's multiplying by negative 4. So let's show that once on each side of our equation. Again, always doing our inverse on each side. So what are you plugging into your calculator? Well, negative 9 times negative 4. What does that get us? It gets us positive 36. Remember, you can check your solution. Do 36 divided by negative 4, hit equals. Make sure your calculator gets you negative 9. All right, let's keep going. Number 13, what's happening to the variable z? We're multiplying by 10. What is the inverse of multiplying by 10? It's to divide by 10. So let's show that once on each side of our equation. Again, just highlighting here our inverse each time. So we are plugging into our calculator negative 100 divided by 10. Negative 100 divided by 10 is negative 10. It should be starting to get easier as we see more practice on this. And remember, this is something we'll also practice in class together. It's also something that you're going to get some practice combining with solving equations by adding and subtracting. All right, so number 14 is kind of a weird question. Negative c equals negative 15. what I do is I write this as negative 1c equals negative 15. Remember that c has a coefficient, a number, and it's 1. In this case, negative 1. So what's happening to the variable? Well, we're multiplying it by negative 1. The inverse of multiplying by negative 1 is to divide by negative 1. So let's show that on each side of our equation. Now, what we're going to plug into our calculators is negative 15 divided by negative 1. Remember, you can do these calculations by hand too, but don't forget to double check in your calculators also. So what will we get? C equals negative 15 divided by negative 1, which is positive 15. You might start to recognize that if you have something like this, like negative c equals negative 15, just drop the negatives on each side and it'll become c equals positive 15. All right, numbers 15 and 16. We're almost there. So what's happening to the variable in number 15? We're dividing by negative 15. What's the inverse of dividing by negative 15? Multiply by negative 15. So let's show that one time on each side of our equation. So the inverse of multiplying or dividing by negative 15 is multiplying by negative 15. There we go. Now, in our calculators, we're going to plug in negative 6 times negative 15. That's going to get our solution for W. That's going to get us 90. All right, number 16. What's happening to the variable U is we're dividing by 8. What's the inverse of dividing by 8? Multiply by 8. So let's show that one time on each side of our equation. Remember to keep it balanced. I did have someone ask me, do we need to show it once on each side? Yes, get in the habit of showing that at this point because the equations are going to get much more challenging, not just this year, but in future years as well. So multiply both sides by 8. It'll cancel out on the left-hand side. And in your calculator, you're going to plug in negative 3 times 8. U will equal negative 24. All right, hopefully those started to get a little bit easier. Let's mix in some decimals and fractions. Remember that if you're struggling with plugging in decimals and fractions into your calculator, please let me know. I can help you. It's a lot easier in person to help you with this, so definitely ask if you're struggling at all. So number 17, 3.8g equals negative 9.88. What's happening to the variable g? Well, we're multiplying by 3.8. What's the inverse of multiplying by 3.8? It's to divide by 3.8. Let's show that once on each side of our equation. So what are we going to plug into our calculators? Well, you're going to plug in negative 9.88 divided by 3.8. That's going to get us g equals negative 2.6. All right, number 18. What's happening to the variable j? We're dividing by negative 7.4. What's the inverse of that? It is to multiply by negative 7.4. So let's show that once on each side of our equation. Remember, it's going to cancel out on the left-hand side, but what you're going to plug into your calculators is negative 2.8 times negative 7.4. And that's going to get us j equals 20.72. All right, let's look at two more, and then I have some independent practice for you to try. Number 19, we have negative 8/9 r equals 1 and 5/27. What's happening to r is that we're multiplying by negative 8/9. So the inverse of that is to divide by negative 8/9. Let's show that once on each side. Now, I will stress to you that next year you might also learn that dividing by negative 8/9 is the same as multiplying by negative 9/8, multiplying both sides by the reciprocal. You may have thought of that last year as like a keep, change, flip kind of situation. Since we're using our calculators though, we can just plug into our calculators. Let me go ahead and box this in. 1 and 5/27 divided by negative 8/9. So I'm going to plug that into my calculator as well. And we should get -1 1/3 for R. If you're not getting that, if your calculator's getting you -4/3, check in with me. I can show you, most calculators will convert that to a mixed number for you. I can show you how to get the mixed number. So again, these are questions you'll want to ask in person. If you know that you're going to forget to ask, just make a note to yourself, like ask Mrs. Garcia about fractions in the calculator. We can look at some examples, and we will do that in class as well. All right, last one. We've got -3 2/3 b equals -32 4/15. What's happening to the variable here, and I put it down in the bottom right, is that we are multiplying by -3 2/3. So the inverse is to divide by -3 2/3. So we're going to divide both sides by -3 2/3. Again, let me just highlight my inverse that I'm using here. My kids are running around upstairs, so I can hear them like elephants upstairs. In your calculators, you're going to plug in -32 4/15 divided by -3 2/3. Be careful. These are really tough to plug in. I'm going to plug it in as well in my calculator while you do that. Whoops, I made a mistake when I typed that in. There we go. All right, and you should get a solution of b equals 8 4/5. So hopefully you came up with that. Again, if you're struggling to plug any of that in, please ask. It does take some practice with the calculators. You're probably going to be a little slow at first, but before you know it, you're going to be able to plug it in as fast as you can text your friends. All right, let's do some independent practice. I've got 4 questions for you to try. Make sure you're showing your inverse operations. Where can you write these? Any place where you have some extra space. So pause the video, give these 4 questions a try. All right, so number 1, we have x over 3 equals -18. What's happening to the variable is we're dividing by 3. So the inverse of that is to multiply both sides by 3. So we're going to multiply both sides by 3. You're going to plug in -18 times 3 into your calculator. You should get x equals -54. All right, let's take a look at number 2. What's happening to x is we're multiplying by -4. So the inverse of that is to divide by -4. So what you're going to plug into your calculators is -16 divided by, oops, this should be a -4. We're going to fix this in real time. I just realized I had a mistake here. So we're going to divide both sides by -4. Whoops, my funky looking negative here. My fault, guys. So we do -16 divided by -4. This should be a +4 for our solution. Actually, let me just delete that negative out of there. This is what happens sometimes when you're typing things, you make some mistakes. I will fix this. All right. There we go. My fault, guys. That happens sometimes. So we divide both sides by -4. -16 divided by -4 is +4 for our solutions. Hopefully you had that right, and I was the only one who made a mistake on that one. All right, let's take a look here at number 3. So we're multiplying y by -2 2/3. The inverse of that is to divide both sides by -2 2/3. So in your calculators, you're going to take 8 4/5, and you're going to divide it by -2 2/3. And that should get us a solution of 3 3/10, but it will be negative since we had a positive divided by a negative. All right, last one. What we're doing to the variable n here is we're dividing by -16.8. So the inverse of that is to multiply both sides by -16.8. So in your calculators, you're going to do -10.2 times -16.8, and that should get us 171.36. Let's take a look at numbers 21 through 24 to start. The directions ask us to translate each of the following sentences into equations. We've already done this with equations that involve addition and subtraction, and we've done it with expressions, and both numerical and algebraic. So let's take a look at number 21. It says the product of 12, it shouldn't say of a 12, of 12 and a number is -48. So we first need to recognize that the word product means multiplication for us. I'm going to put an X for multiplication just since that's the easiest way to show that for me to type it in. So we've got the product, which is multiplication of 12 and a number. Remember that a number is going to be our unknown, so we'll use the variable n here, but you can choose any variable you want. And then the word is generally is going to represent our equal sign, so we'll type that in as well. So we've got the product of 12 and a number, which means 12 times the number n is, which is equals negative 48. So our equation should look like this. 12n equals negative 48. Now, can you put a multiplication sign between the 12 and the n? Absolutely, but you don't need it. Let's take a look at number 22. The quotient of a number and negative 5 is negative 10. So the word quotient means division. So I'm going to use a slash to represent division here, again, just since that's the easiest one for me to show, not a question mark, but a slash for division. The quotient of a number, and again, a number, just like in our last question, is going to be our variable n. So type that in. And negative 5 is negative 10. Don't forget that the word is generally represents our equal sign. Something to keep in mind about subtraction, like we saw previously, and also division, is that division is not commutative, like subtraction is not commutative. So if I'm saying the quotient of a number and negative 5, then the number needs to go on top. So n will be on top, underneath will be negative 5, equals negative 10. You could also write it as n with the division symbol, negative 5 equals negative 10, but just we've seen the problems with fractions, so that's why I'm going to write it here. All right, number 23, the cost of X tickets at $24 each is $432. Since we know that the total is 432, that gives us a good indication that it's going to be equals 432. But then we need to figure out what this first part means, the cost of X tickets at $24 each. Well, if each ticket costs $24, and let's say we buy 3 tickets, we would do 24 times 3 to figure out the total cost. So in this case, we want to multiply. A lot of times when you see the words each or per ticket, you're going to use multiplication or per item. So in this case, we can write 24x equals 432. It's a little harder because there isn't specifically the word product or quotient. Taking a look at number 24, the quotient of 18 and a number is negative 6. So the word quotient, once again, means division, so we'll put a slash there. With the quotient of 18 and a number is our unknown. The thing that's different about this one is the order in which they're written. So the variable is actually going to go in the denominator. We have to read carefully there. I know a student really quickly asked me at the end of class the other day, oh, are these right? And I looked over them and I was like, no, the variable needs to be on top because I didn't read through the problems. So it's important to read carefully. If it says the quotient of 18 and a number, it's going to be 18 over n or 18 divided by n. And of course, that word is going to represent our equal sign. So just be careful. Make sure you read it carefully. If you're in a hurry, just read it, double check it. It's important for all of us, including myself, because I do that sometimes. I read it at first, and I actually had to read this a couple of times to make sure I was reading it as the quotient of 18 and a number, where 18 goes on the top. So it's just something important to double check. It won't happen often. In fact, we're not going to solve equations like this at this point where the variable's in the denominator, but you will see them in future years. And when we start to work with proportions in a future unit, I think it's maybe the next unit we talk about it, you will see variables in the denominator of a fraction. So it is coming up, but just make sure you read carefully, myself included. All right, let's take a look at some real word problems related to this though. So number 25 says, it costs $3 per car to use the hiking trails along the Columbia River Highway. Income from the hiking trails totaled $1,275. A, write an equation that can be used to determine how many cars enter the park. B, solve your equation from part A. So just like when we did our previous solving equations questions, I do strongly suggest that you begin by identifying your unknown. In this case, the thing that we don't know, it tells us right here, it says to determine how many cars enter the park. So I define a variable, C. C represents the number of cars that enter the park. You could even just write C equals number of cars. And I do suggest using a variable that makes sense for the problem. Now going back to our question, we know that it is $3 per car. And C represents the number of cars. So I'm just going to put a C next to this. It's going to be teeny tiny, but It's $3 per car, so 3C. This is going to be 3 times C. Remember a few moments ago I said that anytime you see per item or for each item, you're usually going to multiply? That's the case here. We're going to take 3 times C and set it equal to our total. Our total is usually going to be the number that goes by itself. So we are going to write 3C equals 1,275. Now, I've also had some students recognize that what they need to do to find their solution is take 1,275 and divide it by 3. So they'll write 1,275 divided by 3, which is great, but you've got to make sure you set it equal to your variable. In this case, it's C. So 1,275 divided by 3 equals C is also fine, just like I said when we solved one-step equations by adding and subtracting. All right, let's solve this equation. That is the easier part. The inverse of multiplying by 3 is to divide by 3. We kind of already mentioned that. So in your calculators, you're going to do 1,275 divided by 3. And that means the number of cars. Don't forget a label on your final solution. The number of cars that entered the park was 425. All right, let's take a look at number 26. And again, just like last time when we did solving one-step equations by adding and subtracting, we will see some problems in class on this. We'll also make sure to reinforce this with some other activities that we'll do as well. So I don't want you to panic if you're a little uncertain at first, although my personal opinion is that these questions with multiplication and division are a little easier than the ones for adding and subtracting. So number 26 says Jackie earns $9 per hour babysitting. If Jackie earned $738 last year babysitting, write an equation that can be used to determine how many hours she babysat last year. B, solve your equation from part A. Let's start by identifying our unknown. It says write an equation that can be used to determine how many hours she babysat last year. So my variable is going to be H to represent the number of hours. And we know that she earn $9 per hour babysitting. Keep in mind H represents her number of hours. So $9 per hour, just like the last question, we're going to start off by writing 9 times H, or 9H. Set that equal to the total amount that was earned, $738. So we can write 9H equals 738. Now again, if you recognize that you can just write 738 divided by 9 equals H, that's okay too, or H equals 738 divided by 9. There's other ways to write these equations using our inverse operations, and I'm okay with that as long as it's an equation. Let's solve this. The inverse of multiplying by 9 is to divide by 9. So to find your solution, you will plug into your calculator 738 divided by 9, and we should get a solution of 82 hours. All right, let's move right along to number 27. The highest mountain in Mathville, we see Mathville a lot, Mrs. Garcia is not very creative, is 18,000 feet, which is 3 times the height of the smallest mountain in Mathville. A, write an equation to represent the situation. B, solve your equation from part A to find the height of the smallest mountain in Mathville. So again, for this question, we're trying to find the height of the smallest mountain in Mathville. So let's start by defining a variable for that. H for height, maybe S for smallest mountain if that's a little easier. We know that the highest mountain is 18,000 feet. And we know that that is, so when I see this word is, I know I'm going to have like 18,000 equals, not like, I'm going to have 18,000 equals. And then 3 times is going to be 3 with multiplication sign after it, right? And then 3 times the height of the smallest mountain, well, that's my unknown. So that's H. So I'm going to have 3 times H, and I'm going to set that equal to 18,000. Now I wrote 18,000 equals 3H, or 3 times H. You can also write 3H equals 18,000. In fact, you could do 18,000 divided by 3 equals H. Let's solve this. We're going to solve it by dividing both sides by 3. You're going to plug 18,000 divided by 3 into your calculators, and you're going to get a height of 6,000 feet. So hopefully you have that. Now it's always important to stop and think, does my answer make sense for these questions? Again, we're trying to find the height of the smallest mountain. It should be smaller than, or a smaller number than, the height of the highest mountain, which is 18,000 feet. So always stop and think, does my solution make sense? All right, number 28. This is a higher level question like we saw with solving equations by adding and subtracting, but I think it's good to see. If a number x satisfies 12x equals negative 24, find the numerical value of 4x minus 8. So one of the things that confuses students a lot is this word satisfies. It just means this number x makes that equation true. So you want to solve the equation for x and figure out what x equals. So the inverse of multiplying by 12 is to divide by 12. You'll do negative 24 divided by 12 in your calculator, and you'll find that x equals negative 2. If x equals negative 2, replace x with negative 2 in this expression here, and we're going to have 4 times negative 2 minus 8. 4 times negative 2 is negative 8, and negative 8 minus 8 is not 0, it is negative 16. You can double check it in your calculator if you don't trust me or believe me on that. That's a higher level question. There's not going to be a question like that on your quiz or your test, but it doesn't mean it's not a valuable question because it's a two-part problem, which a lot of real life situations are as well. All right, we're almost done. Number 29, we've got some error analysis questions. Number 29 says, Jordan solved the equation negative 5x equals negative 25 on a quiz. His work is shown below. His teacher marked the answer wrong, but he doesn't understand what he did wrong. Why did Jordan's teacher mark the answer wrong? Explain. Take a look at his work. What do you think he did wrong? If you recognize that Jordan should have divided both sides by negative 5 instead of positive 5, you're correct. Since we've got negative 5 times x, we need to make sure we divide both sides by negative 5, not positive 5. This is a common mistake I see students make. I will also sometimes see students who want to multiply both sides by 5 and think that will work. It will not for a problem like this. The only inverse of multiplication is division by that same number. All right, number 30. Alexis solved the equation x over negative 3 equals 7 on a quiz. Her work is shown below. What did Alexis do wrong? Explain. So if you recognized that Alexis should have multiplied both sides by negative 3 instead of positive 3, you're correct. And I know it might seem like I'm spending a lot of time on simple errors like this, but they're errors that I see students make, so I want you to be aware of them. Again, if we're dividing by negative 3, the inverse of that has to be to multiply both sides by negative 3, not positive 3. All right, our last question. I want you to pause the video and try this one. It asks us to solve for m, where m over negative 5 equals 25. We've got to see these multiple choice questions because a lot of students are making errors on them that they wouldn't make if it were an open-ended question. So pause the video, give number 31 a try. All right, hopefully at this point you've given the problem a try, and hopefully you found that the correct solution should have been choice C. Let's show you why. So the inverse of dividing by negative 5 is to multiply by negative 5. In your calculators, you're going to plug in 25 times negative 5, which is going to get you m equals negative 125, which is choice C. I very often will see students choose m equals negative 5 here because students will see that 25 and negative 5 are compatible numbers. And they'll think, oh, it's division. I'll take 25 divided by negative 5. It gets me negative 5. But unfortunately, that will not make this equation true. I will also have students choose either of these answers, which are just the opposites of these two. So be really careful with the signs on your solutions as well. All right, we will see some more practice on this during our live sessions or during class. You'll also see some assignments given to you where you'll have an opportunity to practice this as well before we take a mid-unit quiz. Thanks for listening.